the flipped Harber for calculus. In this video we're going to cover section 2.2, the limit of a function. Our objectives for this lesson are to be able to explain what the limit is and how to find it, how to find the limits of various functions using tables, and then taking a look at how to find right side and left side limits. Our outline for this video, we'll talk about what a limit is, we'll talk about how to find the limit of a function, we'll take a look at piecewise functions, which will then lead us into right side and left side functions. Now, let's talk about what a limit is. We see here on the screen the notation for a limit, and this is read, the limit as x approaches a of f of x. And the limit is a tool that we use when we want to plug in a number that we probably really shouldn't be plugging in, or a number that we can't plug into a function. Now usually this means that we're trying to find out the value for a function that maybe it would give us 0 on the bottom of a fraction or something. So the limit is a tool that we can use to find out what is that function getting really close to. Even though I can't actually put a specific value at that function because it would have 0 on the bottom, I can see what it's getting really close to. Now, we can never just plug the number into a limit. Now, what I like to tell kids is we make a promise with the limit, we make a pact with it that, okay, limit, I'm never going to actually plug a into the function. And then, under certain circumstances, we'll talk about those in time, we go ahead and we just do it. Okay? So it's a promise that we make, but then pretty much the next section we break that promise. And we just break it under very strict conditions. Now, we're going to look at a simple function to start with and learn how to deal with these limits by looking at functions that we're very familiar with. So let's take a look at this limit where x is approaching 2 for the function x squared plus 1. Now, this is just a quadratic. It's our basic quadratic function that has been shifted up 1. Nothing real surprising going to go on here, but we're going to take a look at how to solve this limit using a table. Since we're making the promise right here that we're not going to plug in 2 into the function, what we're going to do is we're going to take a table and we're going to plug in numbers that are really close to 2. So I want to move closer and closer to 2 from both directions, but I never actually plug in 2 itself. What I'll do is I'll look at the numbers on either side of this table and see if I can make some sort of guess where these numbers are leading me. Okay, so if I plug 2 into that function, or excuse me, if I plug numbers really close to 2 into that function, like I plug 1.9 in, I get 4.61. If I plug 1.99 in, I get 4.9601, so on and so forth. It's probably no real surprise where the limit is taking us. It's taking us to 5. So what I would do after looking at this table and see that both ways my table is leading me towards the same number, I say that my limit is equal to 5. Now, in this one, x squared minus 4 over x minus 2, I absolutely can't plug in that 2. I would get 0 on the bottom of a fraction. But what I want to do is I want to take a look at where these numbers are taking me. What are they leading me up to as I approach from the left and from the right? There's a little key on what we're going to be looking at with left side and right side functions. So when I plug in these various values, 3.9, 3.99, 3.999, are they taking me to a number? 4.1, 4.01, 4.001, are they taking me to a number? Well, sure enough, both sides are taking me to the number 4. So I would say that my limit as x approaches 2 of this function is equal to 4. Now let's take a minute and we'll step back. We're not going to talk about limits for a second. We're going to take a minute to talk about piecewise functions. Okay, a piecewise function has different equations, different rules for me to plug values in depending on what value my x is. So here we see a piecewise function. It's got three pieces, and I've got to plug in based on what my x value is. If I'm interested in finding out what is f of negative 2, well, negative 2 fits into this first piece because negative 2 is less than negative 1. So I have to use f of x equals x squared. Now, if I want to find out what f of 0 is, now I've got to use this middle piece because 0 is between negative 1 and 1. And then similarly, if I want to find out what f of 3 is, I have to use that bottom equation because 3 is greater than 1. So I have different rules depending on what x value I'm plugging in. Now, this is really important when we talk about right side and left side limits, because a right side limit means that we only plug numbers that are slightly larger into the limit. So if I ask what's the limit as x approaches 2 from the right, I only can plug in numbers that are just a little bit bigger than 2. Now, how do I know when I have a right side or a left side limit? Look at this little notation right here. This little notation up here, that's not a power, that's part of our notation that is saying plug in numbers that are just a little bit bigger than a. And then a left side limit, we see a negative in that location. So that negative that looks like it's in the power is telling us to just plug in numbers just a little bit smaller than a. Now, if I want to take something, we've already done this limit. You can see we've already done this table. I've got some numbers grayed out. Those are the numbers that I should not be plugging in because I'm trying to do a right-sided limit. I'm only going to look at values that are a little bit bigger than 2. So, are these numbers leading me to an answer, leading me to an answer for my limit? And yeah, they lead me to 5 again. When I look from the left, are these leading me to a number? Yeah, I'm only looking at one side of this table, but yeah, they're taking me to 5 again. 5 still, really, because we've seen this already. So when this happens, when we see a left side and a right side going to the same number, that tells us something. We'll talk about that in a minute. Now, let's take a look at this piecewise function, though. When we take limits from the left side of negative 1, we have to use that top value, that top equation, excuse me. When we take a limit from the right of negative 1, we have to use that middle equation because if we're plugging in numbers just a little bit smaller than negative 1, I've got to use that top rule. If I'm plugging in a number like negative 1.001, I have to use that top part of the equation. If I'm going to plug in numbers that are just a little bit to the right of negative 1, now stop and think about this, just a little bit to the right onto the number line would be a negative 0.999. Then I have to use that middle piece of this piecewise equation. Now, we run into a little bit of a danger here. What if these don't take us to the same value? Well, when I plug these into my piecewise function, this is what I get, and I should only be looking at the left side when I see this negative. So I only want to be looking over here. When I see this plus, I only want to be looking at the right. Now, when I approach from the left, 1.21, 1.0201, 1.002, those seem to be leading me to 1. So I would say that my limit as x approaches negative 1 from the left is equal to 1. When I approach from the right, I'm taking the limit as x approaches negative 1 from the right. I am also getting a 1. So my two different rules for this piecewise function are taking me to the same value. Now that means something. When I approach from the left and from the right, and I get the same number, that is, I get the same value right here, both from the left and from the right, then this limit without any left or right notation. That limit exists. That limit is equal to 1. Now let's look at another example though. If I want to take the limit as x approaches 1, not negative 1, but I want to approach 1 from the left, from the right, I need to use the appropriate rules. I'm going to use the middle rule as I approach 1 from the left. I'm going to use that bottom rule when I approach 1 from the right. So taking a look at this table, taking a look from the left, I have to look at the left side of the table. Taking the limit as I approach from the right, I've got to look at the right side of the table. When I approach from the left, I start out at negative 0.9, then I go to negative 0.09, negative 0.009. That limit is going to 0. When I approach from the right, 2.33, 2.03, 2.003, that limit is going to 2. So what happens when our two left side and right side limits don't agree? When I take the limit as x approaches 1 from the left, I get 0. When I take the limit as x approaches from the right, I get 2. They don't agree. Well, what that means is that my limit, notice no notation now, the limit as x approaches 1, no from the left or from the right, that does not exist. When you see DNE from me, that means does not exist. So, when we see a limit with no notation up there, from no left or right side, what that actually means is that I need to approach from the left and from the right, and they need to equal. If they don't equal, then it doesn't exist. If the two-sided limits don't agree, then the limit doesn't exist. DNE. Okay, that's it for this lesson. You've got some work to do, so I'll see you in class and I'll see you online.